The spectrum was clean. That was the problem. If a rocky planet orbiting a cool star showed no ozone, no methane spike, no oxygen sitting out of chemical equilibrium, the standard reading is simple: no biosphere. But that reading depends on an assumption nobody really checks anymore. It just gets passed down. Life, the model says, uses liquid water. So life leaves water's fingerprints. So a spectrum without those fingerprints is a spectrum without life. Titan already shows why that chain can break. Cassini spent 13 years mapping a moon with rivers, lakes, and seas of liquid methane and ethane, sitting at 180 degrees below zero. The chemistry in that cold, dense orange atmosphere builds complex organic molecules on its own. No life required. But laboratory work on non-aqueous prebiotic chemistry raises a harder question. If some metabolic process did run on that solvent instead of water, what would it produce? Not oxygen, not ozone, not the red edge of chlorophyll. Maybe nothing that current instruments are built to catch. That's the crack. The search was tuned to one biosphere's exhaust. Every flagship biosignature we look for, atmospheric oxygen paired with a reducing gas, dimethyl sulfide, the reflectance jump of vegetation, is a signature of water-based, carbon-based, Earth-shaped life. JWST's transmission spectroscopy is extraordinary at catching those specific molecules crossing starlight during a transit. It just wasn't built to catch what it was never told to look for. The first explanation for planetary silence is the boring one. Those worlds are simply sterile. And it survives most of the data. Rocky planets around cool stars are common. Strong biosignatures in their spectra are not. Simplicity favors emptiness. But a second clue complicates it. Titan is not an edge case. Cool star systems, which are the targets of most current biosignature surveys, may host worlds with thick, cold, hydrocarbon-rich atmospheres far more often than warm Earth-like ones. If Titan-type chemistry is common, the search isn't failing to find life. It may be failing to ask the right question of the data it already has. A second solvent problem shows up at the other temperature extreme. On hot super-Earths, carbon dioxide can exist as a supercritical fluid, neither gas nor liquid, dense enough to dissolve organics the way water does on Earth. That chemistry has barely been tested in any laboratory. Its waste products, if a metabolism used it, are close to unknown. The atmospheric fingerprint such a world would produce isn't absent from the models. It hasn't been modeled at all. A third case sits on cold ocean moons with ammonia-water mixtures beneath ice shells, lowering the freezing point enough to keep liquid at temperatures water alone couldn't survive. That solvent has its own chemistry, its own possible byproducts, and almost no dedicated search built for it, because those oceans are hidden under kilometers of ice. No transit spectrum reaches them at all. So rank the explanations honestly. Boring. Most of these worlds are sterile, and the null results are simply correct. Physical. Some fraction host solvent different biochemistries producing signatures. Current missions aren't calibrated to pull out of the background noise. Frontier. The whole biosignature framework has a structural blind spot, and confirmed non-water life would force a rebuild of the search criteria from the ground up. The frontier claim isn't proven. It doesn't need to be to matter. It only needs to be possible and untested. The observational limit is real, and it's not a minor one. Transmission spectroscopy needs a transiting geometry, a thin atmosphere, and starlight bright enough to pull a faint signal out of noise. Cold, thick, hydrocarbon atmospheres like Titan's are harder to read this way, not easier. Subsurface ocean worlds are basically invisible to it. No proposed next-generation telescope, including the mission concepts built specifically to hunt Earth-like biosignatures, fully closes this gap. They're built to find more of what we already know to look for. That's the sharper version of the mystery. It's not that the sky has gone quiet. It's that the instruments were pointed at one kind of voice. If you want to keep following this kind of question, subscribe. The next anomaly may be one the current search was never built to catch, either. The honest question left standing. Should the burden fall on the boring explanation, which needs most of the galaxy to be genuinely sterile, or on the frontier one, which needs an entirely different kind of instrument that doesn't exist yet? Titan isn't proof of alien biology. It's proof that the question was framed too narrowly before the search even began.